Thank you, Barton. And I think art of the possible is the right term for all things XR, as we're going to go into in this panel. So we're excited to be the first session of the day in this track. I'm excited particularly for this panel because what we have here are sort of real life adopters on the buy side of the equation. Nothing wrong with vendors and providers, but this is, I think, a less biased take on what's working, what's not working. I really want to dig into like the good, the bad, and the ugly. And I've been talking to these folks, and they're doing really cool things, learning a lot. So we're here to sort of share those learnings with you all. So let's start with intros. We can go down the line. Andrew, why don't you go first?
Okay, my name's Andrew Lowe. I started doing VR for engineering in 2007, kind of on the academic research side, funded by several different projects from several different companies. And that was well before consumer headsets were around, and kind of the cost of entry for VR was, for a crappy setup, like $750,000. And industry penetration wasn't huge then. Kind of came to the conclusion that I might need to pursue other things to get hired. Ended up getting hired for Rolls-Royce, their defense business, doing design automation. I'd done VR and automation research for them for years as well. And then as soon as the consumer headsets dropped the bottom out of the cost of entry, was able to sneak that in under the radar and set up VR for engineering in Rolls-Royce's defense business, and now it's supporting more than 24 different programs in 3 or 4 different countries, and I'm now kind of our global strategy lead for AR and VR.
And Paul, before you go, I learned a fun fact as we were preparing for this panel that Rolls-Royce is in fact not a car company.
Oh yeah, so it's as much as I hate to get this out there because it's my #1 filter question for vendor solicitations. But yeah, we don't make cars. We haven't made cars since the 90s. The car business was always kind of a lost leader, like an engineering showcase to sell jet engines, even in the early 1900s. Well, piston engines then. But yeah, all we do is turbine engines and things that related to turbine engines. Nuclear power, thermal management, that sort of thing.
Nice. Paul?
Yeah, thanks, Mike. Good morning, everyone. My name is Paul Davies. I am a technical fellow from the Boeing Company, Boeing Research and Technology. I've been working in the augmented reality space for actually almost 20 years. I think I'm going like 18 years or so. So I started, actually shortly after I joined Boeing, I sort of met somebody who was at Boeing who was really into AR, and he introduced me to the topic. I sort of got hooked on it back then. I immediately sort of saw the value. This was sort of 2006 timeframe. So since then, I've sort of been pushing the narrative of AR, VR, immersive visualization throughout Boeing's business units. Done some work with government agencies, sort of actually even some spaceflight AR concepts, and then more recently, I would say for 10 years or so, I've been working in the manufacturing domain. Specifically to try to improve quality, reduce cycle time for building our product through better use of digital data. So currently we have a team at Boeing, some of them are in the room here. We're building a product called BARC, the Boeing Augmented Reality Kit, and we're really focused on deploying that throughout Boeing factories and making use of existing technologies, developing new AR sort of technologies for Boeing's interest. Also represent Boeing in the area, the Augmented Reality for Enterprise Alliance. The website is thearea.org. That's a sort of global consortium of companies who are enterprises who are interested in solving sort of common problems around AR. So I've been working, representing Boeing in that organization for about 10 years now as well. So looking forward to the discussion. Thanks.
Thanks, Paul. Diana?
Thank you so much. Yeah, I'm very glad to be here. Thank you for attending. My name is Diana Olynick, and I have been an engineer working in Canada. So I came all the way. I'm very excited to be here by the first time in Long Beach. And I have worked for several years. Most specifically, my role has been in the research and design aspect. And I've been working more specifically in infrastructure. So the governments need a lot of work to do in the field of civil engineering, and I have been specialized in this field. Besides that, part of the research and the design has been also working on new methodologies to improve the engineering processes through more advanced design methodologies, and that has been done also in my personal research that I have published with Springer Nature in a book called Interfaceless. And right now I'm working with the second publication that is about methodology, very important for the field of enterprise, that is called futures design, also related with strategic foresight, which is different to the typical standard planning that is usually happens in regular enterprise. So yeah, that's a little bit about me, and today I'll be sharing a couple of insights that we have gathered throughout the years with these type of implementations regarding immersive technologies.
Thanks, Diana. So let's start sort of high level and level set here. Discussions like these can sometimes become conflated with this like monolithic concept of XR, right? You guys are each working on very specific, formats and flavors of XR, but not only that, the various use cases they map to. So let's sort of define that a little bit at the front end in terms of the types of projects, internal projects you've worked on. We're going to go a lot deeper into each of those, but first let's sort of delineate the types of things you're doing. And let's just go in the same order. Andrew, you can go first.
Yeah, so my personal area of expertise is VR for engineering. So the bulk of that is going to be in the early phases of the life cycle and design, and it's all PC-driven VR. It's when you're doing that sort of thing, you're tessellating NURBS geometry, and that always leads to massive poly counts. Most of what we do is 9 or 10 figure poly count simulation, so you're not going to be doing that in a standalone headset. So, yeah, PC-driven VR. We use a little bit of standalone for marketing purposes. A little bit of pass-through AR for kind of more complex maintainability analysis when you want to be doing something that's a little more complex in terms of human factors, like doing like winter weather maintainability with massive gloves, or something where you'd want to, like when you're working in a confined or obstructed space, you can make little wooden railings and blockades and whatnot. It's just way easier to do that with pass-through rather than trying to align all that with a full VR sim. And then we do a little bit of AR for manufacturing and maintenance.
So processing more important than mobility in your case. And then what is some of the work itself? Is it sort of planning, simulation, or designing facilities?
It's just about anything you can think of anywhere in the process. So we'll be doing a lot of maintainability analysis. We'll be doing a lot of kind of just speeding up spatially complex tasks, like planning out instrumentation routing or harness routing, or if you go later in the life cycle from the AR side, there's lots of spatially complex QA tasks that we do that AR takes it from a week of work to a few hours. We do a ton of planning for manufacturing and human factors for existing manufacturing or other new facilities, but probably the most fun and interesting stuff is repair design as well.
Yeah, and then what? A range of hardware in terms of the make, model, that kind of thing. It's all PC based. You mentioned
it's all PC based, and because we're a defense company, we really only have two choices. It's HTC or it's Vario.
Gotcha.
Because we can't use anything with Chinese hardware, Chinese assembly, because we're a government contractor. So
hadn't thought of that.
Everything HTC is made in Taiwan, not mainland China, and Vario has a all Finland assembled version of their headsets.
And that decision process, I think, is fascinating because I think it exemplifies how every company has a certain set of parameters when you're making those decisions of what to bring in and why. So thank you for those details. Paul, same sort of question, if you could tell us what you're using and why, and the projects and the goals.
Yeah, sure. So from the Boeing perspective, the larger sort of big picture perspective, We probably have over 100, 200 people now working in this sort of space throughout all the different business units for different use cases. So a couple of examples, we do a lot of work producing virtual training kits for customers, both the government and the airlines, that train their employees how to do maintenance procedures and things like that in MRO facilities. We've done sort of factory layout sort of examples. We've developed our own tool for that, actually. Probably there's folks that have used some existing tools for the same thing as well. We've built models of our factories, sort of large, huge buildings in Unity. We call it the IFLT fly-through, so you can sort of visually sort of fly through a factory on a desktop in 3D. We've done sort of ergonomic analysis using VR. Good example I learned out of a facility in Philadelphia. We made design changes to one of our products because we've figured out through a VR experience that some of the parts were impossible to install given the current design, so we learned those things ahead of time instead of when we try to assemble a product. But really the area that I focused on most, as I mentioned during the intro, in the last 10 years has been the manufacturing space. I think it's a huge potential for benefits and realizing those benefits in the factory. Boeing's invested a lot of money in building and developing AR technology, and we really don't sell any of it. We're really doing it for our own internal consumption to improve our own manufacturing operations. So just as an example, the Boeing factory in Renton, where we build 737s, is currently outputting, I think, something like 40, maybe just slightly higher than 40 airplanes a month. That's more than one airplane every single day, so you can imagine the number of operations, the number of people that takes, the number of parts involved, and getting all of that orchestrated correctly so all the jobs are done correctly, they're all verified. I think AR is a huge potential for that, to bring improvements there. So that's where I focus my work for the past 10 years, we've made, I think, pretty good progress, but we have a long way to go in terms of sort of fully implementing that work.
And before we go to Diana, one thing that jumps out there, and we often see this with verticals like aerospace, is we're talking high stakes. You mentioned the volume of output, and we're talking, big ticket items, obviously. Does that compel more so than normal the typical ROI story when sort of selling internally, bringing this technology in, when you have such a large investment to either protect or optimize?
I think it does. And to sort of take that to the extreme, if you look at like a satellite factory where Boeing also builds satellite, those are extremely high value assets and you only get one shot of doing it right. They're very low rate assemblies. Some of the programs are like one per year or even less. So the jobs are done very infrequently. A lot of potential for sort of practicing or rehearsing those jobs in VR and then using AR to get them right. But I think high stakes, high value really increases the likelihood that an AR or VR experience might be more valuable. So
I imagine that applies to you as well, Andrew, in terms of the high stakes factor.
Yeah. For aerospace, the cycle times are very long and the costs are very high. So every tiny little bit that you can cut out is a substantial chunk of money.
Mm-hmm. So Diana, back to that first question, the sort of just level setting on the types of projects you've been involved with.
Yeah, I have a couple of case studies that we have been working with, but the first one is that in infrastructure, particularly in civil, there are a couple of issues when we are conceptualizing or in the early stages of the design. So one of the main examples is that for example, when an engineer is on the field and it's required to come up with fast decisions, there is always gaps of communication between what the drawings or the initial plans are showing and what requires maybe changes in the field. And this affects a lot of the overall budget and costs because sometimes these decisions are made in a way that is more subjective. For example, a case in point is that one day I was even myself in the field when I was working as a project engineer, and one of the contractors said, what happens if we change like 25 feet of one of the installations of the pipes? Can we make a decision soon so that we can all maybe improve this, the flow? And an example like this puts you in a situation where you have to go find the drawings, perform calculations on site, and sometimes these processes take time. And of course, that means money because the contractor has maybe hundreds of people working on the field. So this type of problem prompted also the opportunity to discuss, okay, how can we integrate augmented reality technologies so that we can make these decisions better and maybe faster. The design and conceptual stage of this project was very, very, very hard, intensive, and there are still issues like related, especially with the fact that the integration of the data, like for example, IoT, sensors, and all of these type of assets are difficult to be done in a way that is seamless and that can communicate with other type of platforms that are used to track budgets and costs. So that's one of the works, case study, and the other one is the implementation of IoT and sensors, also with using augmented reality technologies for maintenance. So in the maintenance side of things, for example, implementation of inspections for bridges are usually high demanding work, not only physically, but also, and it involves risks, safety risks, but also it tends to be expensive. So this is a big project that it's being very, very complex because not only the technology has to be there all seamlessly connected, but also the internal infrastructure so that all the data is gathered in a safe way and also the human aspect involved in the implementation. And in my own research, another work that we have been doing is about, typically in design, we tend to focus very heavily, usually in enterprise, in technical requirements, in technical aspects. However, over the years, this is starting to take a little bit of a shift towards how can we have a little bit more of 50-50, technical requirements are very important, but what is the impact of the engineers who are gonna be using this technology, and how can we make that the engineers kind of co-design the implementations of these works rather than having independent designers? How can we make the engineers to actually make these decisions of how this should look like? Because they are gonna be ultimately the only ones using it. But not only the engineers, how about the people that is in the construction field? How can we make them also be kind of designers of the work? So this has involved a little bit more of work in integrating more human interaction aspects in the design, which is a little bit, sometimes it's more heavily focusing in the technicalities of the process. Yeah.
Thank you, Diana. So while we're still sort of defining and level setting here at the front end, the title of this session is all about the product lifecycle and where XR sort of fits in. So each of you have sort of answered this already, but let's put our finger on it in terms of like where you sit or where your XR deployments sit in that product lifecycle and how far it sort of spans. Andrew, you already mentioned that a lot of your stuff is early, right? Planning, testing, stuff like that. But if we could sort of have each of you define that, then we'll kind of move into other areas.
Yeah, it's kind of the general rule of thumb is VR excels when your product doesn't exist yet, and AR excels after it exists. There's some crossover, obviously. You can use VR for designing repairs when things break in a way that you didn't expect, or we use AR occasionally for fit checks for designs that don't exist, especially in our naval division, because I don't know how familiar you are with shipbuilding, but it's kind of the Wild West in terms of how they work. Like they're building ships before their design is locked down. Your first iteration may not be the same as your 15th iteration.
And you have inspections probably that.
So yeah, if somebody wants a design modified,
Yeah.
there's no telling if the geometry you have is accurate to the specific ship it's going on. So what we'll do is we'll put the design into an AR headset and send them out to the ship to do fit checks with AR. But yeah, that's generally how it divides out for us.
Paul, same question.
Yeah, I mean, not a whole lot to add. I would just sort of reiterate the whole, obviously VR is earlier in the life cycle. Once you have something physical to look at, whether it's a mock-up or even a manufactured part, AR becomes much more useful. And then in the support sort of phase, usually both sort of apply. The way I look at sort of my sort of specific work is typically if it's like a Boeing employee in a Boeing facility building a Boeing product using Boeing data, that's where I'm interested. We do, we have some manufacturing that doesn't happen in a Boeing facility, and there's, say, no access to the network. Well, that sort of presents a whole different set of challenges, so I don't tend to focus on there. I think that the four sort of things that I just described capture like, 90+% of our manufacturing, so I really sort of try to develop solutions that fit that. But yeah, that's for my own personal work. So yeah.
Davies, seems like you're also fairly early stage in the way you described it.
Yeah, my focus is in the early design, conceptual stage, and research. And one of the focus areas that I even have expressed myself of very interest has been the study of, as I mentioned, of the factors, the human factors in the whole design process, as well as the exploration of the methodologies of futures design as a methodology for improving long-term strategies. The work that has been done in the public sector is a little bit different to the work that happens in the private sector, because we are creating a product for internal customers, and also we have the maybe review from the public about the work that is done internally. So the design of the strategies in the early design are completely different, and there are always, which maybe in this case is similar to the private sector, but the governments go and work and operate under specific budgets and are scrutinized all the time in how these budgets are being used. So that poses a little bit of a different approach and challenge when in the design process. And in that sense, strategies that have been implemented have been allowed with public consultations in the early design process, so that maybe even not only internally, but also externally in the regions that this is beginning to be designed, what are the opinions of the public and surveys and this type of resources that are used usually in the design. And as particular insights that I have about this focus that we have had is that in terms of engineering or the engineers or the people that is in the field working, really, although it's a new breaking kind of way of working, people really get very excited at seeing initial, maybe early prototypes where they can see the potential benefits of the work in their own understanding and in their own use. And this is something that pretty much super fools the process of the design, because when engineers are trying to propose, or we are even related with the IT and CAD teams, which are related teams that also work in this type of projects, usually we feel that if the design is not properly done, it might pose a lot of difficulties later on with the people that is going to be using the technology. But because the work that has been done in research and design has been including them in the early stages, that has proven to be something that helps to mitigate a little bit of the initial maybe rejections that sometimes people might have of using a different system. Yeah, so usually in the government, there is a lot of difficulties with bringing on board different stakeholders, and most of the work that is done in that regards has been related with training, internal training, to try to mitigate this type of roadblocks.
Thanks, Diana. So now let's move into the ROI points. you've all implemented these technologies because they've been deemed worthwhile for the purposes you're using them for. What were those initial points for each of you in terms of the marks it needed to hit, and how are you justifying the investment on an ongoing basis in terms of, is it, time saved, money saved, productivity boosts? We talked about the high stakes angle, so it seems like no matter what, it's inherently sort of an insurance policy for these high stakes investments. What are the other things that you're using to measure its success and justify it on an ongoing basis?
Yeah, so I'd say in broad categories, the benefit falls into kind of two sections. There's benefit from enhanced understanding of the product you're looking at, and there's benefit from enhanced communication around how you discuss and work with the product. So from like the enhanced understanding side, you're avoiding a ton of rework. You're catching errors that you normally wouldn't see until until you're cutting chips or your customer's taking delivery of the product. And like in the aerospace business, manufacturing a product costs about twice as much as designing one. Sustaining the product costs about 3 times more than the two of those combined. So if you can avoid a life cycle issue early, and do that work in the design phase, it costs essentially nothing, and the savings are huge. So you'll get a lot of that. You'll catch a lot of human factors issues. You will, like I was mentioning, like spatially complex tasks. Like if we're doing instrumentation routing for a test cell, it's incredibly complex task because you have hundreds and hundreds of sensors. A lot of them have to have the exact same length cord, and the signal attenuates the longer the cord is, so you don't want it too long, but if you get it too close, then you'll melt your computer. That sort of thing. Where normally somebody was working for 2 or 3 days just trying to figure out just a preliminary concept. They go in VR and they do it in 15 minutes. And you see a lot of that. And then from the kind of the enhanced communication side, like you don't have the level of cognitive overhead you would if you're standing around a drawing trying to visualize what the product actually is, or standing around a CAD display trying to figure out what the scale really is and how these things interact. None of that's there. You can just point and say, yeah, this needs to change a little bit, or something like that. So like our integration teams, the people that are using, they're using VR to connect our product to an airframe, linking up all of our electronics, the airframe electronics, the pneumatics, the air handling, all that. Their consistent feedback is spending a half hour in VR is taking the place of 3 or 4 weeks of design meetings for a team of 3 to 5 people. And they're running these on their own weekly with, they're investing minutes of their time to set them up. So one thing that I've gotten used to, and talking to other people in the same boat, kind of starting out in XR inside a big company, you have to get used to fudging your benefit numbers, because if you tell people how much you're actually saving, you'll get laughed out of the room and they won't give you anything. We're typically getting ROIs that are measured in orders of magnitude rather than percent.
Yeah. Well, something else you said is interesting too, where there are benefits that go beyond the things that sort of excite the C-suite. But the thing that is often sort of overlooked sometimes in these discussions, which is the end user buy-in. If you're reducing strain or the cognitive load, not just the investment in bringing it in, but it's actually sustainability is being used, because they're sold on it because it has personal benefits, at that sort of end user level. Is that fair to say?
Yeah. There's definitely when we trained our first group of engineers to go up and use VR themselves, there was definitely a huge change in morale.
Yeah, interesting.
Because those 3 or 4 weeks of meetings of trying to get everybody on the same page and trying to, once everybody's on the same page, try to get them to understand the problem the same way and come to the same conclusion. Having that just take a half an hour, it takes all of the conflict and all of the not fun stuff out of designing and just lets you do the fun part of designing.
That's great, and that's great because it counterbalances. I'm not saying this is necessarily the case for any of you, but sometimes we see some resistance from the end users because their guard is up. They naturally see it as, is this thing here to take my job? Or if this makes me 2x more productive, or half of us going to get laid off? So, counterbalancing that.
Oh, that's kind of an interesting thing too. I would have expected a lot of that. Like
Yeah.
one of the things that excites me most about VR is, we have people out on our assembly lines who have been putting engines together for 30 years. We've got people out, maintaining that have been doing it for just as long. It's an enormous amount of knowledge that normally doesn't get used when you're designing a product. And you can start bringing that knowledge into the design phase with VR. You can have them interact with something that doesn't exist the same way they would the products they work with day to day. And I was expecting when I'd start trying to get VR out to these people that you'd get a lot of that resistance to using it, especially from like a lot of the shop floor guys.
Sure. Older generations, perhaps.
Yep. I have not noticed any difference in buy-in based on age, and they have bought into this harder than some of our engineers have. AR especially excites them because they see it as a way where they can compete with robots, because they can get robot levels of error rate and robot levels of speed. But if something goes wrong, there's still somebody with a brain there to make an informed decision. So it's been a surprising lack of resistance on that regard.
Yeah. And I think that's a lesson too, that when deploying the stuff or selling it into any organization, don't focus just on the unit economics, but the benefits to the end users, because sometimes that's where it falls down. Paul, same question about how you're evaluating the ROI and its ongoing justification.
Yeah, I just want to touch on the benefits of the end user, because that's actually a really important point, because the reasons that a user would use the technology are different than the reasons that an executive may want to deploy a technology. The executive is obviously trying to reduce cost, improve speed, improve quality. I mean, day to day, a user may not sort of care about those so much. He's there to get a paycheck, he's there to get a salary. He may, as you said, he may see these sort of things as reducing the number of workers, or maybe eliminating the potential for his overtime. So you've really got to hit both of them. You've got to make it pleasant, or for the user, but also you've got to hit the ROI. So I think on the user side, we've got more work to do, because devices are still issues with devices, usability, all those kind of things. But on the business side, I think we've done a really good job. We actually did a fairly extensive study in one of our deployments in the factory, actually 5 years ago now, where we used a Microsoft HoloLens to show instructions to a set of mechanics, probably about 20 mechanics. And there was a combined use of about 2,000 hours of the software of the platform over 6 airplanes. And then that was around 1,000 jobs, as we call them, installation plans. And then we took the average of the time it took to do those plans and the number of mistakes that were made for the previous airplanes, and then we compared those to the effect of using a HoloLens to view that data in an immersive experience on those 6 airplanes. So a lot of sort of deep data analysis, and the sort of results were we saw around a 20% reduction in time to do those jobs when you used a HoloLens versus using a paper drawing. But at the same time, we saw around an 80% reduction in the defects. So that was really sort of interesting, because you might think if you were going to go faster, build something quicker, you might expect on average more mistakes, or the other way around. If you're going to drive, if you're going to insist on less mistakes, a reasonable assumption is, okay, well, I need to go slower. But in this case, we saw both faster and higher quality. We were never able to sort of scale that beyond the pilot back then because of issues around data, storage, getting data to the devices, usability, the sort of perception of the devices, all those kind of things we might talk about later. But the ROI was very solid. And what's really interesting is a number of companies have done similar studies in multiple industries. Shipbuilding is one I'm most familiar with, but other industries as well. They all sort of point to the same set of numbers, a moderate reduction in sort of time to do a job, but a very big reduction in the number of mistakes or improvements in quality. All these studies, I'm aware of at least sort of 10 of them, they all sort of agree on that. So that to me, there should be no more sort of debate about, what's the value here. The problem we have is actually getting past the barriers of implementation. And so that's where we've really focused a lot of our work more recently. But yeah, I've been really happy and sort of proud of what we've been able to do to show on the ROI side of the
It's almost like you need two separate sales pitches, right? For those two constituents that you're trying to sell to, the end user
Exactly.
and the C-suite. Diana, same question. The projects you've been involved with, how have you sort of evaluated their ROI?
Yeah, in the public sector, there are different indicators, different indexes that are enter into the design process to try to project also and evaluate a potential ROI. And in the design, it has been early performed different research, through the research, different estimations of potential good indicators. One of those ones is the reduction in errors that sometimes happen in the construction sites when, for example, the bridges have been inspected. And this is pretty much the overall reason of this type of implementations, where the idea of, for example, installing sensors in the bridges, IoT information, and also using maybe machine learning systems to try to read data and trying to prevent maintenance delivers as a result something more tangible than sometimes people in the construction site trying to figure out, or maintenance workers trying to figure out only by physical initial inspections if maybe there is a warrant at the moment to perform additional maintenance work. Usually the budgets and financial projections enter into account for this ROI, and in the public sector it works different because it completely depends on assignments of projects for the year. In order to mitigate an implementation like this one, for example, for the case study of the maintenance and digital twins, the use of digital twins, this has been done by reducing the scopes rather than speaking about one overall big project, dividing this big project implementation in very different stages with different scopes to try to manage better the ROI in terms of like how much money is being allocated and how tracking the implementation of each of the different stages. And overall, the most important index is the reduction in errors that directly relates to how much allocation, and at the end of the day in the project, how much sometimes the projects go over the budget, so how much of that savings has been performed during the cycle or the year of implementation. So yeah, that's how it's been working.
That makes sense. So I like this thread of some of the tactical advice that you guys have based on some of these points of resistance. So let's continue pulling on this thread, and let's talk about the fun topic of bureaucracies. So we talked about the points of resistance at the end user level. I think that's important. Where else are we seeing this? You know, the IT department, other points of organizational resistance, and if you can frame that in sort of the learnings you've had and advice for these folks, whether they're working on internal deployments or whether they're selling into enterprises, in terms of the things to consider.
Yeah, so, yeah, we get a lot of organizational resistance. That's unfortunately a large part of my job, but you get kind of your initial resistance you get from the IT department as just if you're wanting to put something on the the official IT estate, your first barrier is always going to be the process for doing that, and depending on your company, that could be different levels of onerous.
And here we're talking about like CAD files, things that are very probably valuable and locked down in terms of.
And then that's the second tier of it is when you get into security and IP. So, everybody wants to protect their IP. Companies like us, like Boeing, we're legally required to protect our IP because a lot of what we're working with is, ITAR export controlled, EAR99 export controlled unclassified, or legitimate classified. So there's always security concerns too, and a lot of misunderstandings of security as well, because a lot of the people in these bureaucracies aren't familiar with the tech. And then you start getting cultural resistance as well. Kind of the first big barrier I had culturally, generally once people use it, they're hooked because it's new and it's fun and you don't really have to sell it to people. Like when I was doing design automation, I was having to put in usage logs because people were lying about using the tools. That's not an issue you run into with VR. So the users aren't a problem, but what I've got a lot of resistance was getting it into new programs, of having the chief engineers thinking that because it has this potential to save them millions of dollars, it has to cost millions of dollars in effort to do, and they didn't have the overhead for time or budget to do it. And it's convincing them, hey, just let me do it. I won't even charge you, just let me do it, that sort of thing. And then the resistance I'm dealing with most now is, now that so many people are bought in, they think too big. They think with too much awe of the technology, and they're thinking, I'll use VR for my my milestone design reviews, or we'll get everybody in the team together once a week to look at what we've done. But there's so much power to it. I'm trying to get them to think in terms of, I should be using this daily, and that's been a big barrier to cross. But if I could offer one piece of advice to anybody trying to start out, it's that bureaucracies are designed to do the things you've already done. They're not designed to do new things. So when you're starting out, you shouldn't really be asking the question, will they let me? You should be asking, can they stop me? No bureaucracy is perfect. There are holes. There are people that have different interpretations of what the rules mean. There's always a workaround. I don't think there's any company out there where you could not legally and ethically work with their data on a computer that's not connected to the internet or any other network. There's a way to get it in and get started. And that's really all you need, because once you're able to, once you save somebody a few $1 million, that's a lot of support for you moving forward. And that's kind of how I did it. I snuck VR in and saved somebody a bunch of money, and then said, hey, I saved this person a bunch of money, can I do this? And just kept snowballing and snowballing until the snowball was too big to stop.
So I think you get the tweetable comment of the panel. It's the forgiveness rather than permission approach. I love it.
Yeah.
So Paul, same question, just any points of bureaucracy that you think are worth mentioning?
Well, I'm going to use the try and stop me line. Thanks for that. That's good. Yeah, what I've sort of, one of the main sort of pain points we've had is sort of true integration of these sort of technologies into the IT ecosystem and the sort of, the whole framework. I mean, there's many different ways to deploy AR. It doesn't have to be a headset. It could be on a cell phone or a tablet or something that's maybe a little more mature in terms of hardware. So there's a lot of benefits there. You can take a tablet that's already available to your user base and maybe make it much easier to integrate. One thing I've learned, though, is, at least at Boeing, the manufacturing programs are kind of where the rubber meets the road. That's where Boeing makes its money. And so everyone else should be aligned to support the program. The research group, IT, everybody, legal, InfoSec should all be aligned to make that program successful. So one thing I've sort of learned is if you can sort of get a program manager who's really sort of into new technologies, show some value, get the program manager to go to bat for you, and then let him deal with IT and InfoSec and everything else, because they have the pull. Being in the research group, we've sort of got limited sort of pull with IT to influence them of like new devices we want to get on the network. Well, some of that might happen, some may not, probably not on the schedule we want. But you get a program manager to say those things, and it will have much more effect. So that's sort of a tactic that we've been using pretty successfully.
And real quick on the sort of familiar, mature hardware point, one just small example to support that. When you look at the competitive field of hardware, one company that's always had sort of a competitive edge, at least in this respect, is RealWear, because at the end of the day, it's an Android tablet. It's an assisted reality device that, from the IT department's perspective, it's Android, right? Yeah.
I agree.
Diana, same question, the challenges, bureaucratic challenges or otherwise.
Yeah, besides the challenges that you explained with cultural difficulties and trying to do these implementations, like our human aspect is one of the important ones. Also, security is very important for the government, like to have the storage of data, how it is performing, all of this, especially with massive amounts of data that is collected, for example, from inspections. And another one that is important is the interoperability and integration with other platforms. For example, when it comes to infrastructure, using platforms like, for example, Bentley systems with MicroStation, and integrating MicroStation with ProjectWise, digital twins. This type of ecosystem, technical ecosystem, becomes a big challenge for implementation because we have to make sure that every platform is speaking the same information and there are not bottlenecks. So browsing in a catalog, like for example, ProjectWise with thousands and thousands of hundreds of thousands of assets in a region alone, and trying to find information and populating everything with all the 3D information plus IoT, plus maybe machine learning information gathered and analysis of that, it requires a huge infrastructure. So technically is a big challenge. And the way that it has been working is also trying to bring additional research experts and people that can even provide better insights on how to optimize the process of implementation, working with platforms like Bentley. But in the process of the design, it has been also contemplated using one of the systems that I guess you use, which is creating their own in-house tools, which is another option, but it's a complex one. So for now, the way to try to cope or manage this situation is by using platforms that are already there that the government trusts that are effective for the use.
Great, so this has 5 seconds. I want to pose one last question, lightning round question, just to cap us off here. I really wanted to get into the hardware, the state of the underlying technology and where it is in its life cycle. So the technology you're all using, in case Meta and HTC and Vario, if they're listening, they're all here. What's your wish list in terms of underlying technology that you believe that could really unlock your next stage of really where you want to get? Quick answers if you can.
Yeah, so for me, more focus on total system latency. I'm trying to deploy VR to every single person. Eventually, I want everybody using it. And to have 98.6% of people be able to use it without issues, you need 20 milliseconds or less of total system latency. Running at 90 FPS, you're burning 22 milliseconds from rendering alone. So all this focus on streaming to Android headsets or moving to cloud rendering, that sort of stuff, it's counterproductive. That's just less people that can use it. So more focus on faster headsets.
That's a good one. And 90 hertz is probably your minimum, right, in terms of usability? Yeah. Paul?
Yeah, mine sort of maybe go a little bit counter to that because I think we need more smaller, socially acceptable devices. I think one big challenge we have at the moment is people don't like the nerd factor of having to wear one in the current generation of devices, and actually consider the current generation sort of a stopgap sort of place. It allows us to understand the benefits of the technology, but it's really not feasible for sort of, at least in the factory environment, sort of scale deployment. So lighter, smaller, cooler in terms of temperature, those kind of things, more likely to make people comfortable wearing them.
Those are good ones. Diana, you get the final word.
Battery life is an important one, especially when we're in the field, in construction, that we need 12 hours of extended work. The size and the weight of the devices right now are very heavy, and it's difficult to offer a worker in the field device that they have to be having maybe in their head for a long period of time. I believe that the technology of AR are going better in this direction, and if it is this technology as well as the best implementation, it needs to be capable of data analysis and easier implementation with these artificial intelligence systems for better data analysis.
Great, that's a good place to end it. Thank you for sticking with us. Thank you all for a fun and enlightening discussion. Please join me in thanking the panel.